I'm saying that to everybody, not just to you, just to clarify. All right, verifying trig identities. The first step's going to kind of be a little bit of a review, so I'm probably just going to do like one of those, and then we'll move into the new stuff. It says find the value of the other 5 trig functions of theta. So basically, they give us the secant of theta equals negative 9/4. And they say that pi over 2 is less than theta is less than pi. So what quadrant does that mean that that's in?
Well, pi is first one because it's half to pi.
Where's pi over 2 to pi? 2. Quadrant 2. Have to review our unit circles. All right, so I'm going to still set it up like I do if they give me like coordinate points or whatever. So I know that it has to be in quadrant 2 and it has to be touching the x-axis. I'm going to switch colors for a second because that's kind of hard to see. There we go. All right, so secant is negative 9/4. So where do those numbers go?
So opposite.
Negative is x. Well, sine is y.
It's adjacent over the opposite, right?
No.
Yep.
I thought it was opposite over 3.
So if we don't know, and so we're not used to working with secant, right? So I would set up, we're solving for all 6 functions.
Oh, we're going back to this.
Just briefly, yes. I don't know why they don't just do this all at the same time, but
Yeah, it's me.
the college algebra book breaks it up about the worst I've ever seen. It does it like every couple sections, it teaches you a new method, and I'm like,
Just do it all at once.
yeah, that's what I'm saying. All right, so I know that secant is negative 9/4, so what does that mean cosine has to be?
Negative 4/9.
Negative 4/9. So cosine is something I am very familiar with working with. So now where do these numbers go?
Adjacent hypotenuse, so negative 4, and the hypotenuse is 9.
Yep, so hypotenuse always has to be positive. Okay, and this is where you've got to really pay attention to what quadrant it's in. I think we had one that we discussed back when we were doing like other stuff about figuring out where things go. But if it was down here, right, and it was tangent, then you would have positive numbers, but you've got to pay attention to what quadrant you're in to make sure you get your x and y values positive and negative where they're supposed to be. Okay, so in this case, x is negative. I know that y is going to have to be positive. So how do I find this other side here?
Pythagorean theorem, because it's a right triangle.
Or you could find the angle.
I don't know the angle, so.
Yeah, you can't find the angle if we don't.
So 9 squared minus 4 squared, and the square root of that is what?
Wait.
I don't know.
60.
Yeah.
Not quite 8.
So it's
I should use the calculator.
Square root of 65. Can this be broken down?
Yes.
How do you know?
5 can go into it.
What is it? 5 and?
It's 5 and 13.
So no, it can be broken down. The only thing I can take out, so it's the square root of 65. So now what's the sign of theta?
Side.
Root squared. Root 64 over 9.
Root 65/9. Not 64. Tangent.
Tangent 65. Yeah.
Cosecant.
Oh, this is the weird one.
9
Square root
square root of 65 over 65.
Yep.
I don't like that.
Cotangent.
Negative 4 root 65 over 65. Is it okay to just say
Why
root?
y'all say
Because like I say root and then it sounds cool, but like some people say square root. Is it just okay to say root 65?
I always say root.
You know, they're taking the monitor out the water at the
What?
monitor
What?
at Merrimack Museum.
At the what?
It's
What?
the anniversary and they're taking it out the water.
I thought you were talking about some like lizard or something.
No.
Oh, like,
What are
you know,
they
they
taking
have
out
the
of the water?
stairs and
Yeah.
then you look
Oh.
in there and they have
Yeah.
those tubs
Museum?
full of the,
Yeah.
full of
Yeah.
the shit parts.
They're taking
That's
out the
cool.
water.
My grandfather has a
This
part from that
weekend.
shit.
Is your grandpa?
All right. Now we're into the new stuff. This is where you need your identities close by.
This one's really confusing.
Huh?
This one's really confusing.
Raise your hand if
The
you know what
identities?
It looks good.
Oh,
you're
they're
doing.
not that bad.
Makes sense.
All right, number 10. Simplify the expression. So we're getting it down to like basically either one single number or like one single trig function based on what we are given. So we've got the sine of x times the cotangent of x. So when I'm doing these, I'm looking at what I'm given and okay, can I break anything down farther than where it is right now? Okay, so I've got sine of x and I've got cotangent. Well, sine can't really be written another way without changing a whole lot of stuff. So can I change cotangent to be written a different way?
1 over tangent.
Okay, I could do that, but that's not going to help me. How else can I write it?
Reverse tangent of 1 over x. Was that this?
Okay, look. So when I'm doing this, I want it in terms of stuff that will cancel. So is there a way that I can write cotangent in terms of sine? Cosine over sine. So I have sine of x times cosine x over sine x. Now, sine x's cancel, and I'm left with cosine of x. And that's my answer.
Wait.
Wow.
No, we got an answer without
Tangent and
numbers in it.
cotangent property. Identity
Correct. Most of
property.
these won't have numbers. If they have a number, it's probably going to be a 1. Like if your final answer is a number.
My third grader brain would blow up.
How did we get the sine x though?
There's tangent and cotangent identity on the notes.
I didn't think it was that funny, but
Like,
Cotangent equals cosine over sine.
oh, okay. Never mind.
All right, 12. Cosecant of theta times the sine of theta plus cotangent squared of theta. All right, so the first thing I'm always going to do is there something I can rewrite to cause things to cancel? Okay?
Yeah.
So, can I rewrite cosecant in terms of sine?
Yeah.
Oh, 1 over sine theta.
Yep.
Right.
1 over sine theta. So 1 over sine theta times sine theta plus cotangent squared of theta. So sine of thetas cancel. So I'm left with 1 plus cotangent squared of theta. Anytime I see a trig function squared, my first thought should be check a Pythagorean identity. Okay? Now when we get into like 14.7, there's some other things where you'll see squared and it doesn't necessarily mean identity. But the first thing I always want to look at when I see a squared trig function is a Pythagorean identity. So, is a Pythagorean identity, is there one of them? That would be 1 plus cotangent squared of theta.
cosecant squared theta.
Yep, cosecant squared theta. And so that would be my answer.
What about the 1?
1 plus cotangent squared is cosecant squared.
Oh, I thought that.
So you can memorize this whole thing?
Yep,
Yep.
Is theta in radians or degrees?
we don't know.
It's really not gonna help.
Can we get a cheat sheet for this?
No.
Yeah, you do yeah.
Wait, really? On the test?
But it's like a quiz.
Oh.
So like on
It's a quiz.
if we're taking the test on Wednesday, then on Tuesday we'll do a cheat sheet quiz.
Oh.
Meaning you will have to write them all down. I will check them, but if you don't attempt it, then or if you just put something down, like I had somebody the other day thinking I was going to give them credit, wrote like 2 + 2 = 4 and thought I was going to fix it for them. Like you've got to be kind of close for me to give it to you.
So will it be a grade?
Just
Is
right,
the
like,
cheat sheet a grade or just to help us?
No, it's just to help you on the test. But if I did it the day of the test, since there's so many of you, and like, I'm not even gonna lie, Pre-cal was awful. They missed so many of their identities. Like, I was fixing something on everybody's. Like, I think there may have been one person that actually got them all right.
So why are we doing the same thing as pre-cal?
Because this is getting you ready for pre-cal.
Yeah.
And theirs are harder.
Pre-cal.
But I'm just saying, they did not really take to heart that I said to study over the snow days. And so when they came in on Monday, they didn't really know them.
They failed.
But if you know, like, hey, I didn't write down any of the Pythagorean identities because I forgot them, then you know on Tuesday night you better study those because I'm not giving them to you. Now, you can write them down on Wednesday on your cheat sheet, but I'm not going to check them for you. So, does that make sense? And I'll give you, like, a blank copy of what it will look like probably tomorrow so that you have to kind of know what it's going to be looking for. All right. 14. 1 plus tangent squared of pi over 2 minus x. So, tangent doesn't have an amplitude, and this is not that. So, one thing to note here that I don't know if I would have pointed out in the notes, but anytime you have like tangent squared of whatever's in parentheses, this is the same as tangent of whatever's in parentheses squared. Okay? Which will be more important in the next section than it is right now. But basically, I'm going to think about this as what is the tangent of pi over 2 minus x?
Does that work for all the functions or just tangent?
All the ones that are squared.
Okay.
So what is, because there's an identity for tangent of pi over 2. It might say minus theta or it might say minus x, but we use x and theta interchangeably. So what is that tell us? Like, what is the tangent of pi over 2 minus x? Should be in your list.
Oh.
Cotangent of theta. Okay, so in this case it'll be x. So 1, that's a plus. 1 plus the cotangent, we keep the squared of x. Okay, so the tangent of pi over 2 minus x is cotangent of x. It was squared, so it stays squared. So what's 1 plus cotangent squared of x?
Which identity?
Yep, cosecant squared of x. So look, 2 totally different problems, but got us to the same ending thing.
Wait,
Yes.
what identity did we use to figure out that the tangent squared of pi over 2 minus x was?
The tangent of pi over 2 minus x is the cotangent of x.
X
And because it was squared, it is still squared.
So
X can be
that was the
X and theta are just variables.
Okay.
Yeah.
So
Oh,
which identity you?
Can I have a cheat sheet?
Do you have your identity thing out?
Yeah, I'm trying to follow.
Okay,
which
where's
one
pi
you
over 2 minus? It probably says theta.
co-functions.
In the note.
There you go.
So is there any way to like intuitively understand this, or do we just gotta memorize everything? Like, does it make sense?
You can learn a song.
Just
I can do most of these without even having to look at an identity sheet anymore.
How?
And is that because you've done them for so long,
Yeah.
or is it because there's just it makes sense if you like?
I mean, like, I think that stuff like this just makes sense. I'm going to rewrite cotangent as something trying to cancel it. So my first thought's always going to be if it's being multiplied by, like, sine or cosine, okay, can I rewrite in terms of sine or cosine?
So why is cotangent cosine over sine?
Because it's
It just
over-
That's
is.
what the notes say, Daniel.
Just honest.
And tangent sine over cosine. It just is. Y over x, x over y.
Okay.
So, Daniel, do you know how tangent equals y over x?
Yeah.
And cotangent is just that flipped, so it's x over y.
So cosine over sine.
Yeah. That one made sense to me.
Okay, that actually makes sense.
That
And
one,
anytime I see, like, cosecant, secant, and cotangent,
just put it.
I'm going to think, okay, 1 over that trig function, but oftentimes with cotangent, I actually need to think about it in terms of sine and cosine, based on what it's being multiplied by.
Everything.
The more you do, so like we do a lot of these, and you will have probably more homework problems with this section because you need to do more to get them ingrained so that you know how to use them.
Okay.
Everything else didn't make sense besides the
Because this year, these stay pretty easy. Next year, these get pretty hard. There's a lot more involved with them. It's not going to seem easy right now, but when you get to next year, you're going to look back on this and think, wow, that was easy.
All about this next year.
And on the AP exam, you don't get an identities cheat sheet. So ingrain them in your brain. The ones I have the hardest time with are the co-function ones. And I mean, I still typically remember them, but that's the ones that I tend to forget.
Oh, I wrote Confucius identities. Why
Co-function.
are we bringing him into this?
Confucius is
That old
dude.
Chinese guy.
What?
Yeah.
Oh yeah, we learned about him in geography.
This is in your garden.
No, we learned him about in the.
Okay, number 16. The cosine of pi over 2 minus theta over the cosecant of theta plus cosine squared of theta.
I don't like this. It's too neat. Dang.
So the very first thing I would do is try to rewrite the cosine of pi over 2 minus theta. Sine theta. So I've got sine theta over cosecant of theta plus cosine squared of theta. Now, can I rewrite cosecant in terms of something else? 1 over sine. So to save having to write this whole thing over again, I'm going to rewrite this as 1 over sine. This is where we need shepherd. Now I have
Why?
something divided by a fraction, so what do I do? Keep, change, flip. Yep, which gives me sine squared of theta plus cosine squared of theta. And that is Pythagorean identity.
It's straight
Oh,
starting
1.
point.
1. That one should be one that just rolls off. Sine squared plus cosine squared equals 1.
Oh yeah, I will most definitely remember this.
That one should be the absolute easiest one.
Like your sarcasm.
I'm not being sarcastic.
No, he was.
Oh. I was like, I'm not being sarcastic.
Very difficult. No, it does not.
How do you
I think this stuff
It
is
was
easier than the last
easier
section,
than
too.
graph
I have
3
no idea
spaces
what
to
that
the
is.
I
left
still
and
can't
up?
move that
Yeah, the
crap.
other one we were just.
How do you guys
All you
say
gotta do
it,
is
but I
move the
won't?
graph.
No,
I literally
This
easier.
makes
All you
no
gotta do is
sense.
look. Right?
To me, these are like doing like not word puzzles, but like kind of like Sudoku puzzles, like in a sense, like not really, because like I'm not very good at those, to be completely honest, but like kind of like that. I'm like, okay, how can I rewrite this in terms of something else so that I can make everything like nice and I don't know, kind of like a game to me.
Not that hard.
And Ryan's like, I don't like your
I like
games.
the graphs because all you do is look at like it gives you the instructions for the graph, and then all you do is put it on the graph like the instructions say.
And then move it.
Right?
It's not hard.
I'm trying.
Yesterday was easy.
All right, 18. Cosine squared of x divided by the cotangent squared of x. And just because I know somebody's going to ask, no, I can't just remove the squares. You don't cancel like that.
Can you remove the x's?
No. All right, so I need to rewrite something in terms of something. Okay, so what's the thing on here that I could rewrite?
Cotangent.
As what?
That's a
You
good
know.
question. I don't know.
Isn't it cosine over sine?
Cosine over sine. And because it was cotangent squared, it's going to be cosine squared over sine squared. Okay, when I rewrite it, this stuff still stays squared. So this becomes cosine squared of x over cosine squared of x over sine squared of x. And again, we need shepherd because why? Keep, change, flip.
Oh.
So I've got cosine squared of x times sine squared of x over cosine squared of x.
And those cosines cancel, so
Yep, cosine squareds cancel, and I'm left with
sine squared of x.
sine squared of x. It's easy once you understand how to use your identities. You have to do a lot of practice with these.
Well, I'm like trying to think about the test, like when you don't have this.
You have it. You just have to study the identities and then you get to use it.
And then you get the cheat sheet. But you have to like actually do decent.
Like at least try somewhat.
But I also put on the cheat sheet like how many of them there are
That's how.
Like that.
Yeah.
so that you know what you're trying to get to.
But what do you mean, like you're actually?
I'm most definitely not gonna get
Stop.
all of them.
Yeah.
Who made
Like you
this?
look.
This isn't cool.
No.
Oh.
You look like
What
a.
is it?
There's a
Oh,
googly
Googly
farm on
eyes.
A video.
When did I see doing this?
8th grade.
I'm gonna make
All right,
it
20. These are getting a little harder. Cosecant, wow,
What?
words. Cosecant squared of x minus minus cotangent squared of x over
That's recorded.
sine of minus x times the cotangent of x.
I wonder what people like who watch the video are gonna think about us later.
How many people are gonna be watching this video?
Probably just Shepherd.
Does she have like 8,000 subscribers? Everybody.
She's YouTube famous.
Oh yeah.
One of my videos has like 4,000 views.
What is it? Wait.
It's an Algebra 1 video, huh?
The
I
great
said
job.
we better not be in it.
Oh, that was
No, it was a COVID video,
Ah.
so nobody was in my
Can
room.
we watch a Christmas video again?
That was so hilarious.
No.
We've got
That next year y'all can make a new one.
You're
I just
remaking
wanna
it,
watch
right?
Junior fundraiser.
Junior
Junior
fundraiser?
fundraiser.
You get money from YouTube.
I'm telling you, let's do a staff versus students basketball game. Sell tickets to.
That's what my dad
Yes.
said we should do. That's what they used to do.
How many points are you?
I'd win.
You'd win.
I don't think that's how basketball
Yeah.
works.
Like just you.
Julia
by
watched me
yourself.
play.
I don't think that's how it works.
Alright, it's decided we're gonna have to do that.
We used to have an alumni basketball game, which there's enough staff that are alumni that'd basically be the same thing.
The people who went to
Someone
the
who
school and then
graduated.
came back.
I don't know what an alumni.
We literally had like an alumni basketball game with the girls early in the
Oh,
season.
this one's gonna be hard.
I want Mr.
We're gonna
It
do
was fun for me.
This is why you need to be on the council for our class.
There's
Apparently, I
double,
don't
You
have
don't have
leadership
leadership
qualities.
there's double.
You can work on it and then do it next year.
I believe in you, Ryan.
No, I'm just gonna leave it.
If it
We
doesn't
can't
work
go
next
into
year, I
junior
don't
year
know
with
what
3
to
class
do.
officers.
Then
We'll die.
All right. First thing that I think of when I see squares are what?
Identities.
Which ones?
Pythagoras.
Yes.
Hey.
If you struggle to remember that, the Pythagorean theorem, everything's squared. Pythagorean identities, they're squared. So, is there one that's cosecant squared of x minus cotangent squared of x?
No.
No.
Is there one that involves those two trig functions? And if so, what is it?
1
One
plus
plus
cotangent
squared.
squared x
Equals cosine squared.
All right, so I see cosecant squared minus cotangent squared. Over here, I have 1 plus cotangent squared equals cosecant squared. So perhaps I subtract this off, and I would get 1 equals cosecant squared. What just happened?
I don't know. You can't ask me that question yet.
Minus cotangent squared of x. My iPad glitched. So now, what is the top of this equal to?
One.
1. So sometimes we have to manipulate.
Oh my
What did
gosh!
we just do?
I like this now.
No, what did we just do?
You take
I took-
the equation and then you move it until it says the thing on the top and it's equal to 1, and then you don't have to do any more work.
Well, on the
Okay.
top.
on the top.
Okay, I took the identities. So a lot of the Pythagorean identities, and that's why I said in pre-cal they get harder, because it doesn't just give you the identities straight up in the problem anymore. They make you manipulate, so that's kind of what we're getting to here as we get to the last problem in this part. Anyways,
How
is
there negative x?
that we've got, I'm not there yet. Okay, we take the identity, the Pythagorean identity, and I see if I can manipulate it. Can I move something over so that it looks like what I have written in my problem? So in this case, I subtracted cotangent squared, and that gave me that stuff on the top is equal to 1. Now, you have an identity, since I'm working with a fraction, I'm not going to like rewrite every little step here. But the sign of minus x, what identity tells me what that's equal to?
Negative angle.
Okay, and so what is the sign of negative x?
Negative sign.
Negative sign of x. Okay, now I know that that's written in terms of, obviously that's sine. So when I see cotangent of x, my thought's going to be rewrite it in terms of sine and cosine. How would I rewrite cotangent?
Cosine x over
Hey.
Yep, so this is on the bottom times cosine x over sine x. Now what happens?
You cancel the signs.
It's just negative cosine.
It's negative.
The signs cancel. And so on the bottom, I have negative cosine x, so I have 1 over the negative cosine of x. What's 1 over cosine?
Is the
Oh,
sign
secant.
Secant, and it's negative, so this is negative secant of x.
Why can't we leave it in the bottom?
Because it's not done.
So we're just
We want it as simple as
simplifying these
possible.
problems.
I could be doing this
For right now, and then I'm about to change what we're
Why would
doing.
they write them so complicated if there's just a simpler way? I mean,
Is there a cheat way?
they
to
should
do
just
this?
write it the simplest way to begin with.
Oh yeah, they are.
I guess somebody asked for
By
that.
the
It's gonna
time-
be a lot of
Technically,
fun.
there's word problems in
By
this
the time you
section.
do
No,
high
please
school,
don't do that.
Like the math
Can
AI
do
is
this.
gonna be so good we won't
I can't
even
do word
know how to do
problems.
this.
I can do computation.
All right, 21. I know I don't normally do an odd one, but this one's a little more complicated, so I want to do it for you.
Savage.
Cosine squared of x times the tangent squared of negative x minus 1 divided by cosine squared of x.
What the heck?
I see squares, so I think Pythag.
Okay, so that is my first thought. The only thing here that I noticed right away is that right now these things are being multiplied. Okay, so yes, ultimately I am going to be thinking that because I see the squares, but I can't do that quite yet because they're being multiplied. Huh?
Can we cancel the cosine square?
No. Absolutely not. Because this is being subtracted over here, so I can't cancel. I would have to be able to factor it out, so I can't do that yet. So, I'm going to first deal with the tangent of minus x. What is the tangent of minus x?
Negative tangent squared x.
Okay, so this is why I'm going to go back up here to what I said. Tangent squared of whatever's inside is tangent of whatever's inside all squared. So, this part on top here, I'm going to pull this off to the side for a second so I'm not having to write this fraction over and over again. This is the tangent of minus x squared, which is minus the tangent of x squared. What happens to that negative when I do that?
It goes away.
It goes away. So this is just tangent squared of x. Okay? Does that, are we tracking on that?
Sure.
Okay. So, for the moment, I'm going to rewrite this as the cosine squared of x times the tangent squared of x minus 1 over cosine squared of x. So, all I've done is I've eliminated the negative x from inside. Now, can I rewrite, right now I've got cosine, can't really rewrite cosine, but can I rewrite tangent in terms of something that deals with cosine to see if something will cancel?
Maybe.
Sine over cosine.
Sine over cosine, and they're going to be squared. So cosine squared x times sine squared x over cosine squared x minus 1. And I'm going to do this because I don't want us to get confused.
I thought tangent was cosine over.
That's
sine.
cotangent. Tangent sine over cosine.
Okay, so tangent sine over cosine. Oh yeah, yeah. Never mind.
The way I remember it is cotangent starts with cosine. Co and co.
Can't start with a cow's head. What's that bottom thing say? Thank you.
Oh, cotangent co. Okay.
All right, so now on top, what can I do?
You
Can
can
you cancel
cancel
the
out the
cosine?
cosine.
I can cancel this cosine and this cosine. And so I have on top sine squared x minus 1 over cosine squared x. Now, Zach, what am I thinking?
Tangent.
No, what you said when I started this problem. squared means
Pythagorean.
Pythagorean identities. Is one of my identities sine squared x minus 1?
No, but you could do the thing.
So
That makes it 1.
sine squared plus cosine squared is equal to 1.
Yeah.
This is where it gets a little different.
Oh,
I don't
negative
think I like this one
cosine
anymore.
equals sine squared minus 1.
Wait.
So cosine squared is equal to 1 minus sine squared. But I'm going to have to basically divide everything by a negative or multiply everything by a negative to get it to be what I want. So this is going to be negative cosine squared is equal to negative 1 plus sine squared. This is why I said this one was harder and I was doing it for you rather than giving you this one for homework.
Thank you.
So
Ryan, this is your
now
fault 'cause you said you liked these.
I can replace the top with negative cosine squared over cosine squared. And what do I get when I do that?
Negative 1.
Negative 1, which is my final answer.
I really did think I liked it for a second. And then you did this.
I couldn't understand why you liked it for a second.
Because it made it 1.
But now it's negative.
And you gotta do more work to get it to a negative 1.
And you have to show you.
All right, so that's simplifying. But what was the title of this section?
Verify.
So we did all that, it's not even the point of the chapter.
Well, it's part of it, but we're not done.
Check it.
So now we're going to verify.
This problem?
No.
I was gonna say, this is too big.
So now we're on to verify.
It's too big.
And I'm going to say, if I can spell correctly, leave the right side alone. Don't touch it.
Oh. I thought she spelled right completely wrong, and then I realized it was capital G.
What did you think it said?
Right. I thought that was a C with like a less than sign.
How?
C? Less than
Why would you put a less than sign on the right?
That's what I was wondering.
Because if we can put letters in math, maybe we can put math in letters. No.
All right, so these problems have an equal sign in them now. So tangent of theta times the cosecant of theta times the cosine of theta equals 1.
No.
You just said a lot of
We lost Daniel, I'm quitting too.
If Daniel
Daniel,
doesn't understand this, I don't know how I'm going.
Is this, we're multiplying all of these?
Yes, they are being multiplied.
Yeah, for sure, no.
Leave the right side alone.
But this is why the part that we did first comes in. We're going to be simplifying the left side to make it look like the right side. Okay? So what I do is I draw an arrow down so that I don't even have the temptation to write anything on that right side.
Never knew I could
You're
be
going a
tempted.
smiley face right now.
Never knew I could be tempted with
All right, so I'm going to rewrite things here. So tangent can be rewritten as what?
A lot of things.
Sine over cosine.
Sine over cosine. So since I see a cosine, I'm going to first think sine over cosine. So sine theta over cosine theta. How can I rewrite cosecant?
1 over sine.
1 over sine theta. How can, or well, I don't need to
Cosine
rewrite
over
cosine.
1.
Cosine theta. All right, so now what happens?
It's 1.
That
1
can
equals
cancel.
1.
Cosines cancel, sines cancel, and I'm left with
1
1 equals 1, and I verified it.
One of them.
So does it have to equal 1?
It has to equal the right side.
Okay.
Because sometimes you can simplify something one way, but it has to look a certain way to match the right side.
I like this a lot better.
My arrow was
I like
too long. I have a
this.
big gap.
That was the first one.
I just didn't draw.
And watch again.
Daniel.
Now, the nice thing about the verifying is you know what your end result's supposed to be.
1.
But I'm going to tell you, sometimes people think, I can trick the teacher and I can just write a whole bunch of random stuff in the middle and just write that 1 equals 1, and she's going to be like, yep,
I'm gonna do that.
false. I won't do that.
Okay.
I will mark it wrong because your stuff in the middle doesn't make sense. Now, sometimes there are multiple ways to get to the same final answer. So I will be looking at that. But I'm not just going to say, oh, they put the check mark that 1 equals 1 and assume.
Check mark.
Nice
It
try,
must
but
be
it's not
right.
going to work for you.
Something on the right side.
Yep.
We should have
Cookie
this
boy.
work day tomorrow.
What?
I drew something on the right side.
Ooh, you did.
Yeah, a check mark.
It says leave right side alone.
Yes, so I don't like I've had people, I hesitate to even say this, but I've had people like subtract things over to the other side. Like you can't do that. They've divided. You can't do that. It's not move from left to right. It's leave it on the right. Leave it on the left.
That's what I was
Ryan, remember that basketball game?
Sine of pi over 2 minus x times the tangent of x
Huh?
equals sine of x.
Oh wait, we know this.
So again,
Black grandmas.
I bring down an arrow so that I'm not tempted to do anything to that right side. The arrow, I can't write on top of it. So, what is the sine of pi over 2 minus x?
Cosine X.
Cosine x. Then, can I rewrite tangent?
Yes.
Sine
Sine X over
of
cosine X.
cosine.
Sine x over cosine x. What happens?
Cosine cancels out.
And sine
Sine
x
equals sine x.
equals sine x.
I like this part. But no, what? Never mind. I don't like it. Because normally when I say that, it gets harder.
$30. 2 minus cosine squared of theta equals 1 plus sine squared of theta.
What?
I still want to mess with it.
Especially since there's a weird thing on there.
Time to draw my little arrow so I can't touch it.
No. But it would be so easy. Just a little subtraction sign.
So it would be.
Would it still give you the same answer? Like if you like really did it?
But that wouldn't be verifying.
But would
We're trying to show that the left is equal to the right.
Oh, okay. I see.
Like we're proving that that's the case. So it's like geometry without actually having to write y. All right, so what do I see?
A sine squared.
A bunch of stuff.
I see something squared, so what should I be thinking?
Pythagoreans.
Okay, but is there a 2, and don't get smart with me and tell me that it's squared. Is there a 2 in the Pythagorean identities? What number is in the Pythagorean identities? 1. So watch, this is going to be mind-blowing, everybody.
2
Watch
over
this.
1.
2 is equal to 1 plus 1.
Whoa.
Minus the cosine squared of theta.
Because of 1
We're
plus
finally
1.
doing math I understand. The 1 plus 1, like, that's the extent of it right now.
The K5 kids could join us. All right,
Oh, no, I
so
don't think they want to.
now is one of my Pythagorean identities in here.
Yes.
Yes.
What is it?
1 minus cosine squared theta.
Would be what?
That's a good question.
What did I say? Negative sine?
No.
No, wait.
This is that's a
Sine squared plus cosine squared equals 1, so 1 minus cosine squared would be
1.
sine.
It's a negative. Oh, wait.
So 1 plus sine squared of theta equals 1 plus sine squared of theta, and I'm done. So if there's like a number like 2 in your problem, consider rewriting it as 1 plus 1 because often that
Have
happens.
anybody ever did
What
that?
about 3? Would 3 be 1 plus 1?
Some people just can't figure out. They're like, that's not an identity, and they can't figure it out.
1 plus 1.
That's why I said watch, because it's kind of mind-blowing to some people that you can do that. Like if it gave you 3, it's 2 plus 1.
Then what?
It's
then
crazy
what
stuff.
become one? So it's just 1 plus 1.
All right. One that's going to take a little bit more effort. 32.
No.
That's fine.
Sine squared of negative x over tangent squared of x equals cosine squared of x.
The sine is
Wait, doesn't
negative.
sine squared x just can they just like
It's negative.
sine squared x?
So this would become, technically speaking, negative sine of x squared, right? So that's just going to be sine squared of x over tangent squared of x. Now, is there something I can rewrite?
Yeah.
The tangent.
Cosine.
Tangent is sine over cosine, so I've got sine squared of x over sine squared x over cosine squared x.
Debate. Change flip.
Insert Shepherd's voice, keep, change, flip. And what happens when I do that?
You get cosine x.
Cosine squared x equals cosine squared x, which was my original starting point. And I'll leave the last one for tomorrow because the bell's about to ring and it's long.
We were just starting to understand what was happening too.
Well, we'll have a quick refresher tomorrow at the beginning and give you your homework problems.
Thank you.
And then you'll have the time to work tomorrow on this stuff. But your homework from yesterday needs to be turned in tomorrow, but you'll have time to do this stuff tomorrow in class. Monday we'll do 14.4, which is using this to actually solve trig functions, and then or trig equations, I should say. And then on Tuesday we'll review test Wednesday and identities quiz on Tuesday.